What if the next big energy revolution was floating? Imagine solar panels, not on rooftops, but offshore, riding the waves. Sounds impossible? Think again. Floating offshore solar is a game changer. It could power millions of homes, reduce land constraints and complement offshore wind. But how does it really work? What challenges come with putting solar at sea? Can it survive during waves and extreme weather? How do engineers design floating solar farms that resist saltwater corrosion, high winds, and constant motion? From cutting-edge materials to hybrid energy farms, offshore floating solar is moving from bold experiment to reality. Could it become a key pillar of our clean energy future? Dive into the future of offshore floating solar. Listen to the full episode now on BlueTech Around the World.
BlueTech Around the World, the reference podcast for blue technologies and ocean innovation.
Hello everyone and welcome back to BlueTech Around the World. Today we are diving into an exciting new frontiers in renewable energy, floating solar panels. Floating solar represents one of the fastest growing sectors in renewable energy, driven by the need for high-capacity solutions in place where space is at a premium. As many of you may know, the potential for floating solar energy is massive. According to the World Bank, it could reach up to 400 gigawatts globally. To give you a sense of scale, 400 gigawatts of floating solar capacity could theoretically generate enough electricity to power around 300 million households, which is the annual energy consumption of a country like Japan. So it's huge. And today we have the pleasure of welcoming Aurélien Croq, CEO of SolarinBlue, a pioneering French startup that's redefining the limits of solar power. Aurélien is an engineer by training, a graduate of the École Polytechnique, and has a background in strategic roles with ENGIE and the French government. Now, at SolarinBlue, Aurélien's mission is to decarbonize electricity for ports and islands by liberating solar energy from land constraints and opening a co-located wind and solar potential at sea. We'll also touch on SolarinBlue's Sète project, an innovative floating solar initiative near Sète in the south of France. So Aurélien, thank you so much for joining us on the podcast today.
Hi, Marie-Lou. I'm very happy to be here and thanks for inviting me.
That's perfect. We are really happy to have you on board. So Aurélien, let's start with the basics. Floating solar technologies has evolved quickly in recent years, and especially as land-based solar become harder to deploy in certain densely population or high demand regions. So can you tell us a bit more about the fundamentals of floating solar panel and why it's gaining so much attention now?
Sure. So the whole idea is that solar PV has made itself, the cheapest renewable energy to implement, especially for large-scale projects. And we've been seeing large deployments in Europe a few years ago, but more and more land use constraints and the lack of space, basically in most developed countries, has driven us towards rooftops, solar car park canopies, and deployment, for example, over lakes. But nowadays, even the lake market for floating PV has become very mature in most developed countries. And now the new frontier is being able to deploy solar PV at sea, where we are able to do so without, of course, any land use constraints. And if we are clever enough, which we think we are, we'll be able also to deploy at sea without any competition of use with other people at sea, and also keeping the costs as reasonable as possible, because floating PV basically is far easier to deploy than offshore wind. So that's a key advantage in the future developments that we are looking at SolarinBlue.
Okay, so if I understand it well, there is really this progress from land solar panel, then solar panel on water with lake, for example, then on the sea in the substructure with co-activities with offshore wind or other coastal infrastructure, and then release the offshore PV at sea. And that's a really good point that you were mentioning the difference with the offshore wind. I'm thinking about cost of implementation, but I'm also assuming the cost of operation and maintenance. So can you tell us, just to get the big lines, how does it work? How do we set up a solar panel at sea?
Yeah, sure. So basically, if you look at our technology, you can look at us as some kind of floating solar car parks canopies. So basically, the idea is that in terms of structural costs, we are very much comparable, again, to solar canopies. Of course, there's the question of having everything floating, but that's something that we solve through technology and innovation. We have several patents on our structure, and the whole idea is that we are able to get a consistent behavior, even in very harsh conditions, for the whole farm, while keeping the cost as reasonable as possible, because we are able to lower the anchoring costs. And for sure, the anchoring is one key point when looking at offshore marine energies. And also regarding maintenance, what one should know is that basically maintenance costs on land are incurred, and that's a bit counterintuitive, but are incurred in majority by the access road, the fences, removing the grass below the panels, etc. And all these costs, of course, for sure, we don't have them at sea. So in fact, we are in very favorable position because at sea, the maintenance doesn't need to be high. And as some of you may know, in fact, it's not the maintenance of solar panels that cost a lot. Solar panels, they are very resistant. They can live their nominal lifetime, especially with our technology that protects them from breaking waves. And the idea is that we're able to get maintenance around the same level as small land-based projects. So we already have very good results in that respect. Maybe we'll talk about it with the experience gained from our first demonstrator, Sète, first offshore solar farm deployed in the Mediterranean.
BlueTech Around the World.
Okay, thank you. So yeah, we have a good view now about the advantages of the solution comparing to other offshore projects. Offshore environment bring their own set of challenges. So can you share some of the key technical and environmental obstacles in deploying floating solar offshore? And how do you address them actually?
Yeah, so there's the technical challenge. Basically, SolarinBlue, we're a team of 10. And most of us are engineers focusing on, taming very harsh conditions. So the specifications that we have for our system is 14-meter waves, okay, and 200 kilometers wind. Why is that? Because we plan on deploying our technology, you said it, for ports and islands, but also in collocation with offshore wind. And there, this is far offshore environment. And then you have very harsh conditions. So the strong innovation that we bring at SolarinBlue with our technology is that we are able to deal with such waves, 14 meters again, while keeping the structure as low over the water as possible, meaning that we have an elevation of the solar panels that's something around 2 to 3 meters, depending on the conditions, for the bottom of the solar panels. And why we elevate in heights comparable to solar car park canopies, for example, we are able to sustain very harsh conditions. And we proved our technology offshore in waves of almost 9 meters in March of 2024. And that's real life experience on real size demonstrator in Sète. And so we are now very much confident that we unlocked the possibility to install solar panels at sea, even in difficult conditions, thanks to this technology that's overbuoyant, meaning it really rides the waves, and with our patented link between floaters that enables to connect the floaters to one another, and then get some kind of a carpet effect where the whole farm also rides the waves, of course, without any collision between the floaters. So really, that's where we are active, and the solutions we found to unlock the potential of real offshore for solar.
That's amazing, because when we think about water and electricity, usually it doesn't mix well, and also salt water can cause this extreme corrosion. And as you are mentioning, waves and huge waves, when you go more offshore and offshore, can bring significant mechanical stress. So yeah, good point. First, elevating the structure above the wave, the water, and also have this connected infrastructure, such as a network of them, to move with the flow of the water. So yeah, that's really impressive to see how you address this technical change through this patent and innovation. Just one question. So just to give our listener a good overview, what the size, how does it represent concretely this kind of installation? For example, in the Sète project?
Sure. So the Sète project is a demonstrator. So that's 2 floaters of 9 by 12 meters. Okay, so that's rather reduced. But if the audience wants to get an idea, basically the energy density that we have on our floater is the same as what you would experience on land. So basically 1 megawatt means 1 hectare. But where we believe that we are really getting the most from offshore is that 1 hectare offshore has nothing to do with 1 hectare on land. As you can imagine, the ocean is very vast, and you have plenty of room to settle. And if we take the example of offshore wind, one should know that windmills are typically separated from one another by 1 to 1.5 kilometers. And that means that rapidly you have very vast offshore wind farms. And when you look at offshore solar, we are able to settle inside an offshore wind farm with the same capacity and same power installed for solar and wind, but using only 10% of the area of the offshore wind farm, meaning that the energy density is far better with offshore solar. And that's also what makes us confident, in terms of social acceptance and the possibility to carry other activities such as fishing while producing also solar energy on the same site.
Wow, that's amazing to see the difference between the energies that you can provide and the space. And as you mentioned, it's really important for social acceptability. We saw that regarding marine social planning and to organize different activities at sea. You are mentioning fishermen, but we also have different activities, marine transportation, tourism, marine protected areas, and also offshore wind, for example. So we know that places at sea beginning to become really expensive and rare. So it's to know that we have solutions that can provide a lot of energy without having such a big footprint on the maritime space. Listening to you, I was also thinking, comparing to other kind of marine renewable energy, about, what we say about wind. It's also the fact that there are some seasonalities, if it's winter, if it's summer. So regarding solar panel, what are your criteria to choose a place to set up offshore solar panel site, for example?
So yeah, you're right. Definitely irradiance. That's basically the quantity of sun that you get over a given place. The irradiance, of course, plays a critical role, right? So we are targeting first the places where the irradiance is the highest. So that's why we settled our first project in the Mediterranean Sea. But that's not the only criteria. If we want to keep the costs as low as possible, we have to be as close as possible to shore. What's important is that offshore solar has very little visual impact. As I said, the structures are elevated just a few meters above the sea level. That's nothing to be compared with the offshore wind turbine reaching 100, 200 meters high. So we can settle very close to shore while having no visual impact. And then when we find the proper space close to shore, the idea is to try to find it as close as possible to a consumption zone or to an injection point. That's the idea basically for ports and islands. But for offshore wind and solar collocation, it's a bit different, and the underlying concept is exactly what you said. Offshore wind and offshore solar have different seasonalities. Basically, offshore wind will produce mostly in winter and at night, while for sure solar PV production takes place during daylight, of course, and mostly in summer. So that's the whole idea of co-locating the two marine energies together. It's because you can rely on the same cable, a cable that's been designed in the first place for the offshore wind farm only, and you are able to export both electricities through that cable, that existing cable, that when you put it in place, you had no idea that one day you would add solar PV to it, offshore solar. And that's possible due to the complementarity, the highest complementarity possible between offshore wind and offshore solar. And that's a very strong result, of course, because that unlocks the potential of, marine zones where you already have energy production. Your government already decided that the social consensus goes towards these places to install energy production. And there you settle without any additional big investment, and you use only 10% of the area of the offshore wind farm. So that's a great deal. And that's why we think that the concept of hybrid farms with offshore wind and offshore solar is basically the boulevard in front of us.
Sometimes I love to ask some business question regarding go-to-market, market penetration strategy. And here we can see that these co-activities and the linking and partnership with other activities that is such as offshore wind will give you the access to infrastructure and also to all this licensing and authorization from the state government and also the public, the consultancies for the citizens. So yeah, it's good, and I think it's a really good strategy. So congrats for that.
BlueTech Around the World.
And regarding all this authorization, I know that there is now a big concern about how to assess and mitigate the environmental impact of all offshore energy. See how at SolarinBlue do you manage these different impacts that you may have on the marine environment?
Sure. So if you allow me to expand a bit on the environment and, all the regulatory aspects. So first of all, regarding the environment, the whole idea of deploying a new marine energy and new renewable marine energy is, of course, to have the smallest environmental footprint possible. So how do we achieve that? First of all, by not covering the sea with solar panels. That's very important. Solar panels are elevated, meaning that the air can flow below and that all the oxygen, for example, that's exchanged between the ocean and the atmosphere, can be exchanged as if we were on there. So that's one point. Second is, of course, the shading that we bring with the solar panels. And to reduce that impact, what we do is basically that we separate the floaters from one another with corridors. And these corridors allow sunlight to go below the solar panels. And also like to say that there is really a lot of light going below the panels, because we also get some light reflected by the sea because we use bifacial panels, meaning that we get, the direct sunlight, but also the indirect sunlight reflected by the sea and all the diffuse ambient light. So there's definitely light coming and going to the ecosystem. And that's very important for sure, because our objective is to both deploy renewable energy, but also to have the best environmental impact. And there's also very positive aspects of having floating structures at sea. And the first one is basically what we call biofouling. It means that the structure gets colonized by mussels, for example, and all the immersed parts have a biofilm and mussels on them. And we see that very well in Sète. So that's a challenge in terms of engineering, because they definitely weigh a lot. So we have to take that into account to keep the structure floating correctly. But this is also something very positive, and it's been shown to be positive by offshore wind and floating offshore wind projects, for example, where we see that this is something that brings life back to some places. So we have the ambition, first of all, not disturbing the ecosystem, and second, bringing more life in places where you would have some already for sure, but we give the possibility and we provide a new habitat for other species. So that's for the environmental part. And for the regulatory part, because of course the public authorities have a role in making sure, that we preserve the environment, but they also have a role, in my opinion, in favor of the development of new renewable marine energy. Because as soon as we prove that in terms of environmental impact it's interesting, then they should support us in settling, for example, inside the offshore wind farm. And there's something that I think is very important, is that some European legislations, and the French one is not the best in that respect, have made the offshore wind developer kind of the ruler of the whole area. And as we said, this area is rather large. We need just 10% of it, but he has most of the assets there, and then he's able to prove or not the fact that we settle inside. And there we think that it's really something that should be closely monitored in France and in other countries to make sure that the state decide who will be able to settle inside the wind farm, because windmills, it's just points spread throughout the zone. And there's something to be discussed there, because also it's a question of sovereignty, and we need to be very cautious about it to make sure that existing and farms that will be built within the next 5 to 10 years have the right authorizations and everything that enable later on to add offshore solar or even tidal or any other renewable marine energy that's able to take advantage of the publicly funded substation.
Yeah, and I think it's a really important point that you just mentioned, that in the tendering process that we need to think long-term and we need to think co-activities. And so it's really important to give the space to have other technologies inside of an offshore wind area. And also that even if they get permit or a license, that other actors could fit. For example, if you take only 10% of space and you can provide energy with a good impact on the environment, that you could be also part of the project. So I think it's really important that we need to push for more like interdisciplinarity for sectorials with different technology that could all bring their own advantages. And having this in mind in the tendering processes to be sure that we can adapt to the big objective we have with Green Deal, but also to the new technologies and innovation advancements that comes up and will continue, I'm sure, in the future. So yeah, I think it was a really important point that you mentioned. And also to come back on the environmental discussions that we just get. It's funny because you are mentioning that, of course, you limited the actual impact on the environment. You don't disturb, for example, the oxygen exchange between the surface to the water column. So no impact on the marine ecosystem, for example. And you go deeper with having a positive impact with all this marine ecosystem. And we saw that also on offshore wind, where more than just being a hotspot for biodiversity, it also become a nursery. And there's some aquaculture project, for example, with oyster farmings that are being implementing around this offshore wind area. But I'm imagining for your engineers teams that should be really difficult to have in mind all these biopooling specificities to manage infrastructure offshore. So it should have been a great challenge for you. I'm just curious because you were talking about the demonstrators in Sète. Since you have been able to demonstrate the efficacy and all the value of your project, what are the next step for SolarinBlue? Is there a new project in your pipeline, in your roadmap? What are the next big step for you?
Sure. So first, I'd like to reflect a bit on the success from Sunset. So we discussed it before. It's about resisting 9-meter waves. Really, that's huge with the first version of the prototype. So really, we're very proud of that. But this part is really the mechanical, structural, hydrodynamics part of the job. But there's also the question of how much electricity does it produce. And Sunset in that field has provided excellent results, and we get 6% more PV production than a comparable onshore project. So that's really interesting because it shows that the economics are going to be better offshore than onshore. And this is proven on the field where we had to deal with bird dejections, where we had to deal with sand particles coming from the Sirocco winds, for example. But if you take all that into account, when you factor in the lower temperature, when you factor in the bifaciality of the panels, when you factor in the fact that in fact the solar panels are working very well at sea, no corrosion problem, then in the end you have a 6% more production offshore than onshore. And this is really building on both aspects, structural and electrical, that we managed to move to the next step. And the next step is Sète. And the next step is 1 megawatt project that we come at the same place as Sunset. Basically, we would decommission Sunset and replace it with Sète. And Sète is a project that's been co-founded by the France 2030 program. So that's basically French government subsidies. And we work on that project alongside with Technip, Observatoire Océanologique de Bagnols-sur-Mer. So that's basically the Sorbonne University, specifically working on oceanologic projects, and also the University of Montpellier. So that's the main project that we are looking at right now, and we have the ambition of commissioning it by end 2025, early 2026. And this 1 megawatt will be, of course, the whole floating farm, but also a floating transformer unit and the dynamic cable. And we will bring the electricity to the port of Sète, and it will be used to power the port and especially bring some renewable electricity for onshore power supply, which is basically the electrification of boats.
Wow, that's amazing. If all the different sectors of the blue economy, you with more renewable energy, the port, and also marine transportation with the cold ironing and the electrical port supply, it's amazing. So I'm really happy because I live in the south of France. So maybe I will have the opportunity to see it firsthand. So yeah, it's amazing that you have the support of the different partners. And I saw you were mentioning that you are also working with research institute and research centers to also support you in this adventure. So congratulations to all the team. I think with all these steps and all this adventure running SolarinBlue, you have a good view on the innovation and technologies that are running in the sectors. So according to you, what are some of the most significant technological advancements shaping this field? And where do you see the biggest areas for improvement? For example, you were mentioning you are focusing on elevating and also this network. In the introduction, you were also talking about the anchoring. What do you think would be the next move, the next innovation for offshore solar panel?
So basically, the challenge for us is to get the structure as light as possible and to lower the elevation of the panels as much as possible. To do that, we can, of course, improve, the ingenuity of the design and everything. But as soon as we can rely, on lighter and more resistant materials, that's interesting. So there's a whole field of improvement in terms of materials. Then there's the question of the anchoring. There is really room for innovation. As you know, for floating offshore wind, the idea of sharing anchors is something that's new and needs, a lot of innovation. We definitely have the same requirements, and we see the same opportunity, probably even more than offshore wind in sharing the anchors. And for sure, there's the efficiency of the solar panels, because we definitely create square meters at sea, where we are able to deploy solar panels. So the more efficient they are, of course, the cheaper the electricity we produce is. So there's really the question of, the materials, basically the setup, the anchoring, and then the solar PV technology. And what's really a good news, also coming from Sunset, is that mainstream solar panels work very well at sea. You don't need, specific equipment and everything. So we can really take advantage of all the improvement made in, latest announcements from mainstream manufacturers. And this is something that, will drive also the economics down.
Okay, good to know. And regarding the global market, after Sète project, I'm sure you're going to go internationally developing your solution in all the sea of the world. My question is there some countries, areas, region where it would be easier and with more potential? I'm thinking more about, if there are some governments that pushing for this other kind of renewable energy, not only focusing on offshore wind, for example, but open it the way for other kind of technologies. But I'm also thinking of having the right industry partners, the ones that build materials, the one that will do the setup and do the offshore work at sea. So I think it's really important to have all this combination of industry and stakeholders along the value chain ready to this kind of project. So in your opinion, is there some region in the world that are, more open and pushing for this kind of project?
Yes, there is. So first of all, I'd like to say that France is a very nice country to start this activity, because we have a very strong offshore industry. We have a lot of offshore wind projects. We have very long coastlines. We have very high irradiance coasts. We have overseas territories, etc. So first of all, I'd like to say that I feel that we are lucky we're French, and again, I'd like to thank the public authorities for supporting us, for example, in doing Megaset. So that's one thing. And then, of course, there's the question of how do we accelerate and how do we become best in class. So the country that's today the most advanced in terms of offshore solar, it's a bit counterintuitive, but it's the Netherlands. And why is that? It's because the Netherlands, they have, that culture of, gaining space over the sea. We all know about the polders and everything. And they have already deployed lots of offshore wind farms, which, as we explained, are one of the best places to settle. So they are the first, and they already allocated a 50 megawatt block of offshore solar inside an offshore wind farm. And the project is supposed to start in 2027, construction. So the idea is that, of course, we are competing to get that project. And then there's Italy. So everyone, I think, expects more Italy than the Netherlands. But Italy, as you know, there are big mountain chains inside Italy. So they don't have that much, space available for solar PV. And they also have ambitions for offshore wind. So the co-location are starting to appear there. And the developers are really, it's not like in France where, the government decides the places where you will settle. There, it's the developer's choice, right? And they can propose virtually any location. So we believe that's something that, really helps in terms of regulatory framework. And so Italy is very good in that respect. And that's why also we see some projects coming from there. We see Greece, because they have a lot of islands, and they also have lots of land use constraints. Greece looking at the possibility to develop offshore solar with also ambitious targets, around 2 gigawatts by 2030. For the Netherlands, it's going to be 3 gigawatts by 2030. And there's Malta, 50 megawatt project there. So they are really, at the starting point, but it makes a lot of sense for an island like Malta to gain back sovereignty on electricity. During the prices of electricity in 2022, they paid the electricity around 400 to 500 euros per megawatt hour. So that's crazy. So they're definitely considering offshore wind and offshore solar in co-location. And we see the first project coming in Spain also. So generally speaking, we see that Europe is, very much leading the way. And France there is not the first, but not the last also. We need to go faster. We need to make it easier to develop projects inside wind farms. But we feel that there is really some market potential, strong market potential in France. And then there's Asia, of course. So the Chinese are looking big. They have rather nearshore projects for now, but totaling around 1 gigawatt. So you see, it's crazy. And islands in the Indian Ocean, in Southeast Asia, and in the Caribbean are also very interesting territories and prospects for new projects. So basically, to make things clear, offshore solar, we see it ramping up throughout the world in many geographies for many reasons. but we see that Europe has what it takes to be a key global player.
Thank you for this good overview of the market. And what I can see also is that you were mentioning in your market, your go-to-market strategy, it's also that it's very much linked to the offshore wind market. So we're the one who are developing and pushing their industry and their value chain to support this green energy and ecosystem.
But I'd like to reflect on that. It's really, we see, for example, that offshore wind is kind of slowing down right now. Again, the whole strength of the co-location concept is that you can settle on existing wind farms, meaning that even if offshore wind slows down and then, accelerates again, for us, there's already the whole stock of offshore wind assets that we have, and we have a lot in Europe. So that's why we believe that there is really room for a full ramp up for offshore solar, regardless of dynamics of other marine energies, because there's all this already existing potential that we are ready to conquer.
Yeah, you don't need to wait to surf the wave of the new
Exactly.
projects that are coming.
Exactly.
There are already a lot of farms, a lot of wind areas, so you can already focus and set up and mix your solution of offshore solar panel, with this existing infrastructure. And that's a really good point. Thank you for pointing that up. Okay, one question, because I think that our listeners are really interested about this topic. Is there any event or conference you plan to attend this year where some of our listeners can meet you and know more about your future project?
Sure. So there are several floating solar PV conference. So the audience can Google them because there are several. We'll be in almost all of them because we get invited by the organizers as one of the key players. You will be able to meet us in Synergy also. It's around June. And for the second part of the year, it's not still yet decided, but basically each time there's a big renewable mine energies conference, we are there. Either we have a stand or we come as visitors. But it's very easy to know about the news from SolarinBlue. Just subscribe to our LinkedIn and contact me, of course, directly. I'll be happy to answer any questions and and set up any meeting that the listeners would like.
Thank you, Aurélien. I'm sure our listener will appreciate that. And just because I saw that we are running at the end of the episode right now, if you have some advice to give to some people who want to go in the maritime world and launch their own BlueTech startups or new innovative solution in the blue marine energy, what advice would you give to them?
I would say be bold, be innovative. We know that the marine environment is very harsh, and hence, we have built, a lot of standards, constraints, and everything. Of course, there are reasons for that, but there are also reasons to overcome them when you do something new. In fact, most of what's been decided before does not apply. So don't hesitate to take, very bold technological bets. If you are good in what you do and you have the right, appetence for innovation, you might very well be right. And just 4 years ago, a lot of people would look at us like, oh, it's not doable, whatever. And then we see the power of sunset. We see how Megaset is gaining attention. We see this market growing. So really don't hesitate, innovate, and, take some bets. I'm sure it's going to work out.
Thank you very much, Aurélien. And I think you're right. And also that you could have these demonstrators is also the possibility to have a showroom of innovation, demonstrate the efficacy, that it's reliable, and to have more and more partners around the table from the finance part, I'm thinking about a lot of entrepreneurs that are looking for funds. So Blue Investors, I know that there are some impact funds to support this kind of project, but also all the industry and all the public authorities. So I think it's really important to have this kind of showrooms and demonstrators to have everyone around the table and supporting this kind of amazing project. Before we close it, there's something that you want to add, something that we didn't talk about during our discussions that you think would be really important for our listeners to know?
Maybe just, highlighting the fact that despite all what you may hear, solar PV is really a way to gain back sovereignty on electricity production. I think that's very important, especially in the context that we have right now. Solar PV panels, they are less than 5% or 10% of the costs, total costs. So don't be afraid of solar PV. We definitely need more. And if we can do that while keeping the land for agriculture, which we know is also a topic of very big interest in terms of sovereignty, it can be better for everyone. So really, we believe that offshore solar has a key role to play, especially in the difficult times that we live in right now. And it's going to help on the decarbonization part for sure, but also on the sovereignty part. And I think we see the value of both today.
It's really important, and I think you just quote the hot topic of all the maritime political agenda. I know it's all about data and artificial intelligence, but it's also about the sovereignty of our data, but also about our energy. And having also this solution, not only rely on the traditional one, but having this portfolio of innovative solution at sea, where France has a leading role, but I'm also thinking of European Union and all other countries. So it's really important that you mentioned that and that we have this in consideration when making the right choice for our sovereignty. So thank you very much, Aurélien. It was a great pleasure to have you discussing this topic with me. I'm sure our listener love to know more about floating solar panel because it's not something that we think has a really easy when we hear about it for the first time, but it seems really promising. And as you mentioned, it's not something that we saw as like a crazy innovation for the future that may appear sometimes, but something really concrete now should be part of the discussion and part of the marine renewable energy project. So thank you very much, Aurélien, for being our expert guest today.
You're welcome, and thank you very much again for inviting me.
So for all our listeners, that's part of today's episode. Be sure to check the description for more detail on SolarinBlue and ways to connect with Aurélien.
BlueTech Around the World.